Space is vast, dark, and mysterious. It's a cosmic dance floor where galaxies swirl and stars ignite. But imagine this: a supermassive black hole, a giant among stars, veering off course, warping the fabric of space-time itself. This cosmic journey won't be a sprint, but a marathon spanning millions, even billions of years. We've always known about these celestial giants lurking at the hearts of galaxies, including our own Milky Way. But something has disturbed this cosmic choreography, setting it on a collision course with our little corner of the universe. Until now, they've played by the rules, anchoring their galaxies in a celestial ballet that's gone on for eons. Supermassive black holes evoke a sense of awe and terror. These objects are millions, even billions of times the mass of our sun, squeezed into a region smaller than our solar system. They devour anything that ventures too close, their gravitational pull so strong that not even light can escape. But how do these behemoths form? The answer lies in the life cycle of stars. Stars are born from collapsing clouds of gas and dust, ignited by nuclear fusion. Eventually, even the most massive stars exhaust their fuel and collapse under their own gravity, sometimes resulting in a supernova explosion. At the heart of this cosmic maelstrom, a black hole is born. Over eons, these stellar remnants can grow, merging with other black holes, pulling in gas and stars, until they reach supermassive proportions. These gravitational giants then take up residence at the centers of galaxies, shaping their cosmic homes. As they devour matter, they release tremendous amounts of energy, often in the form of powerful jets that can stretch for thousands of light years. The discovery of a supermassive black hole veering off course is both exhilarating and unsettling. What could possibly knock a supermassive black hole off its trajectory? One possibility is a close encounter with another galaxy. Galaxies can drift close to each other, their gravitational fields intertwining in a cosmic dance. When two galaxies collide, the results can be spectacular, flinging stars out of their orbits and sending supermassive black holes careening off in unpredictable directions. Another possibility is the influence of dark matter, which forms vast, invisible halos around galaxies. It's possible that the distribution of dark matter in the vicinity of this rogue black hole has been disrupted, creating gravitational imbalances. This disruption could have nudged the black hole off its path, sending it hurtling through space. These interactions can have dramatic consequences, altering the course of cosmic events. Imagine a cosmic game of billiards with supermassive black holes. These gravitational titans, lurking at the hearts of galaxies, move and interact with each other, shaping the cosmic landscape. When galaxies collide, their central black holes spiral towards each other, locked in a gravitational dance. Stars are flung out of their orbits, gas and dust are heated to millions of degrees, releasing blinding bursts of radiation. This cosmic ballet reaches its crescendo when the two black holes finally merge, sending shockwaves through the fabric of space-time. These gravitational waves carry the whispers of these cataclysmic events, providing us with a glimpse into the most extreme environments in the universe. The study of these mergers is revolutionizing our understanding of gravity, black holes, and the evolution of the universe itself. The universe is a dynamic, ever-evolving tapestry of creation and destruction. Supermassive black holes are now recognized as fundamental players in this cosmic drama. They are the architects of galaxies, their gravity sculpting the distribution of stars and gas. Understanding how these black holes form, grow, and interact with their surroundings is crucial to unraveling the mysteries of the universe. As material spirals towards the event horizon, it forms a swirling disk of superheated gas, known as an accretion disk. These accretion disks are some of the brightest objects in the universe, outshining entire galaxies. Black holes can also launch powerful jets of energy and particles, influencing star formation in their host galaxies. In this way, black holes play a vital role in regulating the growth and evolution of galaxies throughout the universe. A supermassive black hole heading our way sounds like the plot of a blockbuster disaster movie. But remember, the universe operates on vast timescales. We're not talking about an immediate threat, but rather a cosmic event that will unfold over millions, if not billions of years. Even a supermassive black hole is a tiny speck compared to the vastness of interstellar space. The likelihood of a direct collision with Earth is astronomically small. However, as this black hole approaches our galaxy, its gravity will begin to distort the fabric of space-time around it. This distortion will affect the orbits of stars in its vicinity, potentially sending some careening off in new directions. Our solar system could be affected, but the chances of us being flung out of the galaxy are slim. The more likely scenario is that we'll experience some gravitational jostling as the black hole passes by. The universe operates on a timescale that dwarfs our own fleeting existence. Stars are born, live out their lives, and die over millions, even billions of years. Galaxies collide and merge, their central black holes locked in gravitational dances. Amidst this cosmic ballet, life on Earth emerged, evolved, and developed the capacity to contemplate its own existence. The discovery of a supermassive black hole on a collision course with our galaxy is a stark reminder of our place in the universe. We are but a small part of a much grander story, a story that began billions of years ago with the Big Bang. But this discovery is not a cause for despair. It's an opportunity to marvel at the wonders of the cosmos and deepen our understanding of the universe. The vast timescales involved give us ample time to prepare and develop technologies that can mitigate any potential threats. Imagine a future where we can manipulate gravity, travel to other star systems, and unlock the secrets of the universe. To understand the universe, we must look back to its very beginning, to the moment of creation. In a cataclysmic event called the Big Bang, everything exploded outwards, expanding and cooling over billions of years. The echoes of that primordial explosion can still be detected today in the form of cosmic microwave background radiation. This radiation provides a snapshot of the universe as it was just 380,000 years after the Big Bang. As the universe expanded and cooled, gravity began to exert its influence, forming the first stars and galaxies. These early galaxies collided and merged, their central black holes coalescing into even more massive objects. The discovery of a supermassive black hole on a collision course with our galaxy provides a unique opportunity to study these cosmic behemoths and their role in the universe's evolution. The universe is a symphony of light and gravity, of matter and energy, of creation and destruction. To understand this cosmic symphony, we must learn to read the language of the universe. Astronomers are like cosmic detectives, using telescopes to gather clues from across the vast expanse of space and time. We study the light emitted by distant objects, analyzing its spectrum to determine their chemical composition, temperature, and motion. We observe the gravitational effects of massive objects, measuring how they warp the fabric of space-time. The discovery of a supermassive black hole on a collision course with our galaxy is like finding a new instrument in the cosmic orchestra. By studying this rogue black hole, we can learn more about the nature of gravity, the evolution of galaxies, and the ultimate fate of the universe itself. In the grand scheme of the cosmos, our planet is but a tiny speck of dust. And yet, on this tiny speck of dust, life emerged, evolved, and developed the capacity to contemplate its own existence. The discovery of a supermassive black hole on a collision course with our galaxy is a humbling reminder of our place in the cosmic order. It shows us that we are not immune to the forces that shape the universe. But this realization should not fill us with fear or despair. Instead, it should inspire us to appreciate the preciousness of life and the uniqueness of our planet. We are the inheritors of billions of years of cosmic evolution, the product of countless generations of stars. The universe is vast and full of wonders waiting to be explored. The future of humanity lies among the stars. As we continue to explore the universe, we will encounter new challenges and opportunities. The approaching black hole is just one example of the cosmic forces that will shape our destiny. We are a species of explorers, of innovators, of dreamers. We have the capacity to understand the universe and our place in it, and to use that knowledge to shape our own destiny. The approaching black hole may seem like a threat, but it's also an opportunity. It's an opportunity to test our limits, to push the boundaries of science and technology. Imagine a future where we can harness the energy of black holes and travel to other star systems. The future is not predetermined, it is up to us to create the future we want to see.